on 7.2, special right triangles. There's going to be relationships that are true for just certain right triangles. Now, the thing is, these are big right triangles, are going to come up a lot, so it's a good trick to know. All right, let's say we want to find y in this right triangle. Well, now, what do we know about, this is an isosceles triangle because these two are the same. So an isosceles triangle, then this side is going to also be 5. So now we can do the Pythagorean theorem. 5 squared plus 5 squared equals y squared. That's 25 plus 25 equals y squared. And then we have 50 equals y squared. Take the square root. And let's see, if we reduce that, that's going to be what? 25 square root of 25 times the square root of 2. So 5 radical 2 equals y. Okay, so this side is 5 radical 2. 5 radical 2. Let's try another one. All right, on this one, we know the side is 2. So we know this side is 2. So 2 squared plus 2 squared equals y squared. So 4 plus 4 equals y squared. 8 equals y squared. Square root both sides. And I have the square root of 4 times the square root of 2. That's 2. Radical 2 equals y. All right? So this is 2 radical 2. Now you're seeing what I'm seeing, hopefully. 5 radical 2 across from the 90. 2 radical 2 across from the 90. All right? So we're going to be able to figure these out. All the time there's this relationship. All right? So if I don't know x, if I don't know this one, this is x. This is going to be what? X radical 2. Okay? So now we have a relationship here we've built. So here we go. Every 45, 90 degree triangle has sides with the following relationship. Now you can think of it in terms of two ways. This is going to be similar triangles, and this is a, more of a straight up formula per se. But they are both derived from this triangle. All right, so the sides are going to be 1, radical 2. All right, so I know right off the bat, if this is 4, this is 4, 4. This is going to be 4, radical 2. Okay? The 90, the radical 2 is always across from the 90. If you want to find that, you could use this as well. Same thing. Say it was 4, so my leg was 4, so the radical 2 times 4 is 4 radical 2. You can use either one you want. So let's do it. In fact, I'll show you both ways. All right, let's use similar triangles first. So I'm going to make this similar triangle. I'm going to draw it. And I know this is 1, radical 2. So I'm going to use a proportion. So x over 1. X over 1 is the same as 6 over radical 2. Okay, so x divided by 1 is just x. I need to rationalize this. So I'm going to multiply by radical 2 top and bottom. So 6 radical 2 over 2. The 6 divided by 2 is 3 radical 2. Alright? Can totally do it this way. This is the way I've always done it. I've always done it with similar triangles where I draw the triangle the way it's oriented, alright, and I set up a proportion and I solve it just that way. Alright? I've not done this. This is not how I'm used to doing it, but I kind of like it. So if you like this way, you can do this way. So I'm just going to take what I have. I know the hypotenuse is 6. So 6 equals radical 2 times the leg. Well, I don't know the leg, so I have to divide by radical 2. So the leg equals 6 divided by radical 2. Again, we have to rationalize. So 6 radical 2 over radical 4. 6 radical 2 over 2. And again, it gives us 3 radical 2. 2, Sullivan. 2, man. 2. Make it a 2. All right? So that's that. You can do it either way you want. I'll try and mix it up and show you both ways as we go. All right? All right. So let's try this one. Let's do the formula. So the hypotenuse is radical 2 times the leg. I'll do y. So I want to solve for y, so I need to divide by radical 2. So now I know it's 9 over radical 2 equals y. I need to rationalize it. So 9 radical 2 over square root of 2 times square root of 2 is square root of 4, which is 2. Right? There we have it. All right. I'll do this one with a similar triangle. So I'm going to draw my triangle. All right. And I know that this is my 90. So these are my 1, 1, and my radical 2. Now I know y right off the bat. These are always the same, 1 and 1. So y is going to be radical 6 over 3. All right. Now a lot of you don't like fractions, and that's okay. So let's do this one. So radical 6 over 3. Divide, I'll put in over the same side over here. The same side is 1. And then x over radical 2. All right, so let's simplify. Anything divided by 1 is just itself. So radical 6 over 3 equals x over radical 2. Multiply both sides by radical 2. They cancel here. Radical 2 times radical 6 is radical 12 over 3. Square root of 12, so that's the square root of 4 times the square root of 3. Square root of 4 is 2 radical 3 over 3. Alright? A little more involved, probably because of the fraction. Now, I'll be honest with you, I tend to stay away from fractions. I like to put them in notes, make you do them, but I tend to stay away from them. Alright? So 45, 45, 90 triangles, that's the big one. 1, 1, radical 2. The next one is 30, 60, 90 triangles. And it has sides with the following. Across from the smallest side, 30, is a 1. Across from 60 is radical 3, and this is actually square root of 3 is 1.7-ish. And across from the biggest angle is the biggest side, 2. So it's easy to remember 1, 2, 3, but the 3 has a radical on it. All right, and then all you have to remember is that they go in order. Smallest angle, smallest side, medium angle, medium side, largest angle, largest side, and something, something, something. All right? Now over here, the bad thing about the formulas on this is we only really have 2. We don't have one that has the hypotenuse and the long leg. So when you do these, if you want to do the formulas, you're always going to have to get it back to the shorter leg. So the hypotenuse is just twice the shorter leg. So if I know my hypotenuse is, or if I know my shorter leg is 4, I know my hypotenuse is 8. It's always double. Nice. I like double. That's easy. Likewise, if I know my hypotenuse is 12, this is half, or 6. All right? Down here, the longer leg is radical 3 times the shorter leg. So if I know the shorter leg is 7, so then the longer leg would be 7 radical 3. All right? And again, you can do these similar triangles or by plugging them in. Let's do the similar triangles first. So across from 60, this is going to be the radical 3 side. Across from 30 is going to be 1 and 2. So let's find this. Well, see, and some of these are so easy you don't need to set anything up. Seriously. I know this is double. So double 4 is 8. Piece of cake. Let's find y. So 4 over 1 is the same as y over radical 3. Bring that up. 4 radical 3 divided by 1 equals y. Divide by 1, well, you just get 4 radical 3. Okay? You could have done that with the formula. All right? The longer leg formula here. The longer leg is equal to radical 3 times the shorter leg, 4. 4 radical 3. All right? Sometimes I think it's easier to use this formula. I kind of like it. But sometimes if I get confused or if I'm not sure which formula to use, I always draw this similar triangle and then I do it up. All right? All right, so let's try this one. So we'll do the first one by the formula, maybe? Yeah? Okay, so the longer leg, so this is the longer leg, is radical 3 times the shorter leg, right? So the longer leg, so 2 radical 3 equals radical 3 times n. Divide by radical 3. n equals 2. And what do I know about the shorter side on the hypotenuse? It's always double, so if this is 2, this is going to be 4. Piece of cake. Alright, let's do this one with the similar triangles, just in case you like that method. Whoa, that's awful. So this is going to be 1, radical 3, and 2. Alright, now here's why, no, either way, it would have worked. Alright, so let's try this. So 5 radical 2 over 2 equals, let's see, n over 1. So n over 1 is just n. And so we're just left with, because this doesn't simplify, 5 radical 2 over 2. So now we need to find our longer leg. Well, our longer leg, if you remember, is radical 3 times our shorter leg. So radical 3 times our shorter leg is 5 radical 2 over 2. So radical 3 times radical 2 is 6. So I have 5 radical 6 over 2. And that would be m. All right. Ooh, we could crank it up a little bit here. Let's crank it up. So I want to find x, and this is if that's a 90, this is 90, right? I don't know any of these sides, but I know this is 5, and this is a shared side. So if I can find this, we'll call this y. If I can find y, I can find x. So let's see here. I know the shorter side, and I want to find the longer side. So what's my longer side? Longer leg equals radical 3 times shorter leg. So here we go. Y equals radical 3 times 5. So y equals 5 radical 3. So we're good with that. Now we're in a 45, 45, 90. If you remember, that's 1, 1 radical 2. So here, the hypotenuse is radical 2 times the leg. So x is radical 2 times, what was my leg? Well, my leg was 5 radical 3. So radical 2 times radical 3 is 5 radical 6. Radical, man, that's radical. All right? I know, corny math joke. It's okay. All right, so Mr. Kelly, Mr. Brust called him over to move up some boxes to the second floor. He knew they could do it because it's on the Big Bang Theory using math. Let's go to that clip right about now.
I guess we'll just bring it up ourselves.
I hardly think so.
Why not?
Well, we don't have a dolly or lifting belts or any measurable upper body strength.
We don't need strength. We're physicists. We are the intellectual descendants of Archimedes. Give me a fulcrum and a lever and I can move the earth. It's just a matter... I don't have this. I don't have this. I do not have this.
Archimedes would be so proud.
Do you have any ideas?
Yes, but they all involve a Green Lantern and a power ring.
Easy.
Easy.
Okay. Now we've got an inclined plane. The force required to lift is reduced by the sine of the angle of the stairs, call it 30 degrees, so about half.
Exactly half.
Exactly half. Let's push. Okay. See, it's moving. This is easy. It's all the math.
What's your formula for the corner?
What?
Awesome. Sheldon kills me. Love it. All right, so they measured the floor and realized the longer leg was 12 feet long. How far did they move it? So the first thing I always do with these, I'm going to draw a picture. That's my strategy. When I do my ICAN, consider strategy, my strategy I always consider in geometry first is draw a picture. Piece of cake. Along the floor. So along the floor would be here. So this was 12. And they want to know how far they moved it up the stairs. And this was X. Now, did you hear in the clip it said the angle was 30 degrees. They ballparked it at 30 degrees. All right? All right, so we want to find how far they moved it. So we know this is the hypotenuse. This is the longer leg. See, now this is the one, we don't have one straight between the longer leg and the hypotenuse. To me, that means I'm going to automatically go for a similar triangle. So I got 2, I know this is 1, and this is radical 3. So here you go. X over 2 is the same as 12 over radical 3. I'm going to multiply that up. So x equals 24 over radical 3. And I'm going to rationalize it. And I made it 24 radical 3 over radical 9, which is 3. 24 goes into 3, or 3 goes into 24, 8 radical 3 times. Now, that doesn't tell me a darn thing, because this is a real-world problem. I need a real-world answer. So I'm going to estimate it, and if I put that in my calculator, I get about 13.8 feet. All right? So pause the video. I want you to try these two. All right, here we go. Let's light it up. So this one we have, I'm going to do the hypotenuse is radical 2 times the leg. Divide by radical 2. So 2 over radical 2 equals the leg. Rationalize it. 2 radical 2 over radical 2 times radical 2 is radical 4, which is 2. Those cancel, so I'm left with radical 2. So x and y here are going to both be radical 2. All right, over here I need to find, oh, here's my common side. This is going to bridge the gap for me, isn't it? So I'm going to go from here, I'm going to find y, then I'm going to use y to find x. All right, so this is a hypotenuse, and this is a longer leg. Ooh, can't do that one again, so I'm going to draw my similar figure. So this is 2, and this is radical 3. So 7 over 2 is the same as y over radical 3. Multiply that up. So now I have 7 radical 3 over 2 equals y. Now I have to do it again. So now I'm using this to find x. So I know this is 7 radical 3 over 2. So 7 radical 3 over 2, that whole thing is the same as which side? 2. So over 2 equals, and then I have x over radical 3. Now this looks nasty, but when you divide a fraction divided by a fraction, what do? Well, I divide by the reciprocal, right? So 7 radical 3 over 2, divide by 2 is the same as multiply by the reciprocal, excuse me. So that's really just 7 radical 3 over 4 equals x over radical 3. Multiply both sides by radical 3. Radical 3 times radical 3 is radical 9. Square root of 9 is 3, so this is 7 times 3 over 4, which is 21 over 4. Woo! That's a tough one. Not going to lie to you. That was tough because of the fraction. But I have confidence. So good luck on that. Make sure you ask any questions you have before you take the master check. Remember, always better to pass that master check the first time. All right? And you do that by doing the practice problems, learning from your mistakes. If you get through those practice problems and you have no idea how to do it, why in the world would you take the mastery check? Go to your teacher. Ask for some more help. All right? Get some more practice problems. It's okay. All right? Best of luck. Peace. I'm out of here.